Okay, let's talk about radian angle measure. So when you talk about radian angle measure, in your calculator, you're going to see it as rad. So it's going to have the constant of pi. So what this is based on, it's based on the ratio of the arc length in a circle to its radius. So since it's a ratio of the arc length to its radius, so we want to highlight ratio of the arc length in a circle to its radius. So it's going to measure the amount of rotation from the initial side to the terminal side. Okay, so when you're talking about an angle measure, so say you had 4 quadrants, and you're going to have an angle measure from a circle. So let's say we draw a circle. It's not going to be perfect, but it'll be close. Okay, you're going to have sides like this. And what you're trying to measure is going to be the angle, which we can call theta. So as we're talking about the amount of rotation, we're saying that the rotation is going to be the traveling around the circle. That's a rotation. So you can continue to go around the circle and you can have multiple rotations. So amount of rotation from the initial side to the terminal side. So you're going, the initial is the start to the terminal side, which is going outward to the left. So when you have this information, you're saying that you have the distance around a circle, and then you're saying that that's the circumference. So now that I'm saying that the distance around the circle is the circumference, we're also saying that it can be a rotation. So in this case, you have c equals 2 pi r, and you're saying that pi is a constant. So since pi is a constant, you're also saying that pi is equal to 3.14, but we use only pi now. Okay, so then from here, we're going to say that we're going to use radians, or rad, or rads, however you want to say it. So the radians are going to consider the unit circle. So you're going to say that r equals 1. So when we talk about the unit circle, we're saying that this right here is my unit circle. Okay. So one other note that I want to make is I want to say that the distance around the unit circle is 2 pi. Okay, and if I wanted to convert it, it'd be approximately 6.28. So you're also going to say that radians radians use pi to symbolize the angle measure. So the angle measure we were talking about is going to be theta. So this right here is theta, which is a Greek letter. Okay, now I want to talk to you about, let's just take a little break. I want to talk to you about angle measure and circles. So we're talking about angle measure and circles. We're saying that we're going to use the unit degrees. So it's DEG, or it's the symbol for degrees. And we're going to talk about degrees of circles. So when we're talking about degrees of circles, you have a full circle, so if I have a full circle, everything's filled in, it's equal to 360 degrees. If I have a half circle, it's equal to 180 degrees. And this next one is very specific. This right here. If I have a right angle, it's equal to 90 degrees. So it's a right angle. So definitions basically are saying that if I have a radian, 1 radian is the measure of the angle, or of the central angle, that intercepts an arc equal in length to the length of the radius. So when you do that, you're constructing an angle of measure, which is going to equal 1 radian. So you're constructing an angle of measure, which is equivalent to 1 radian. And I'm telling you what a radian is. Make sure you get all that. Okay. So next, we talked about degrees. So now let's talk about a full circle is going to equal 2 pi radians. A half circle is going to equal pi radian. and a right angle is going to equal pi over 2 radian. So let's talk about the conversion. So next what we want to do is we want to convert so we're going to talk about the conversion of radians and degrees. So the conversion of radian degrees is pretty simple. So to go from degree to radian, you're going to multiply by pi divided by 180 degrees. And then to go from radians to degree, you're going to multiply by 180 degrees divided by pi. So I want you to remember that pi is a constant. Okay, so here's our first example. So this is example 1. And you're going to go degree to radians. So 120 degrees equals how many radian? So you're going to say 120 degrees. You're going to multiply pi divided by 180 degrees. And we're going to work downward. So then I say 120 degrees pi divided by 180 degrees. I'm going to simplify. So right here, you're going to reduce. And you're going to say 2/3 pi radian. So you're bringing this unit down. The next example, so example 2, say we have negative 45 degrees. So right here you're saying degree to radian. So you're going to say negative 45 degrees is equal to some unknown radian. And say negative 45 degrees multiplied to pi over 180. You're going to keep on working, and I'm going to say negative 45 over 180 degrees pi. And then we're going to say that equals this right here. You're going to reduce. And I'm going to get negative pi over 4. And then bring this down. Radians. Okay, so now we're going to go radians to degrees. So it's RAD 2 degree. This is example 3. So I'm going to multiply 5 pi over 4 by 180 degrees over pi. So as I rewrite this, you're saying 5 pi over 4 times 180 degrees over pi. So what happens with the pi is that the pi is going to cancel out. And then when you multiply, you're going to multiply going across. So that leaves a 1 here. It's supposed to be a 1. When you multiply going across, you're going to have 5 times 180 degrees divided by 4. And then you're going to say that that's equivalent to 225 degrees. So right here, you're going to simplify. Okay, let's look at the fourth example. And you don't need to put degrees, you just need to have that little symbol right there. So example 4, say you have 3 pi over 2 radian. And I want to know what are the degrees. So you're going to say 3/2 pi times 180 divided by pi, because we're using the second conversion. So as I rewrite this, I'm going to say 3 pi over 2 times 180 pi. The pi's cancel out. Then you're going to say I have 3 times 180 degrees divided by 2 is equivalent to 270 degrees. So right here, I simplify.